What we're going to do on this multifunctional gas control valve is we're going to check and make adjustment to the burner pressure of the appliance. It's important that if a burner pressure is adjustable and checked before you undertake any other tests on it, before you gas rate it, before you do any heat input calculations. If a burner pressure is set incorrectly, then it's going to be using too much gas or too little gas, which is going to mean your heat input and gas rate values are incorrect. The manufacturer will explain where and how to make adjustments to it, and they'll give you the data which you adjust it to. It'll either be found in the manufacturer's instructions or, in this example, on the appliance data plate just inside of the case of the appliance here. So what we need to do firstly is connect our U gauge to the correct side of our multifunctional gas control valve. If we follow the gas supply into the appliance, it comes up through here. We've got an inlet test pressure point there. We've got our start button, so straight away we know it's got thermoelectric FSD. We've got our appliance regulator there, and we've got a burner pressure test point there. The manufacturer will explain where these are. It's important to make sure you're on the correct test point. Down here is a pilot light adjuster screw. Don't get that confused with the burner pressure test point, because if you start tightening that, the appliance will not light. So you need to leave that well alone. We're looking at that point there. Okay, our burner pressure test point. Now what we always need to do, remember, is connect our testing equipment to our appliance with the gas supply isolated. Now just down this side here we do have an appliance isolation valve, so we're going to use that for the purposes of this. We're not going to go back to our gas meter. So we can now safely connect our testing equipment. With the test screws on these, unlike on our gas meter, the test nipple on our gas meter, we do not remove them fully. We loosen them off 3 or 4 turns. Okay, that's all we need to do. Now then, we're going to connect our gauge to that. Okay, put that on there. Now what I've done, a little hook of solder just to hold the U gauge securely, because we don't want that to be falling off. It is a point of weakness on the installation, so it's nice and well supported. What we can now do, we've got our equipment on, we can reinstate the gas supply and we can light the appliance. With the appliance alight and with the main burner on, we will record a pressure on our U gauge, which is our burner pressure, which we can make reference to on the data plate that side of the appliance. So gas back on. That is on nice and securely. Press and hold the start button and spark. What we're looking for would be our pilot light down there. Okay, there's no need to continuously click it. Okay, every 5 or so seconds, just a click is absolutely fine. Once our pilot light has established, which it has down there, we hold it in for a few seconds. That allows the 15 to 30 millivolts travelling up our thermocouple, energising the magnet within our multifunctional gas control valve. The pilot light is now staying established. What we can now do is put a demand on this appliance. What we're now seeing is the main burner has ignited, and we are now recording a pressure on our U gauge. Again, like any time we're using our U gauge, we want to make sure we're reading equally on both sides, so we're going to adjust for scale. We are recording 15.5 millibar of burner pressure. Okay, we can see that on our gauge at the top there, 15.5 millibar. Now if we make reference to the appliance data plate, which is here, that is at the highest setting. Which is fine. It may well be that this appliance does require that, but what we're going to do, I'm going to show you how we would adjust that. And what we're going to do is, I've taken the dust cap off of the appliance regulator. The dust cap has been removed. Now in there is the regulator screw. We can make adjustment to that. If we wind it in, we're going to reduce the flow of gas to our burner, so our pressure will be reduced. We're going to reduce it down to 9.2 millibar, which is the lowest setting. So a small turn, and let's see how the reacts. Okay, don't sort of rush to do this. Nice slow steps. Okay, give it time to react. We're looking for 9.2. We're down to 13 millibar at the moment on our gauge. Now at 12 millibar. Okay. At 9. We're now at 9.2 millibar. Okay, so what that means is we've now adjusted it to that setting, which in turn means that we've now got a heat input of 10.15 kilowatts gross. We'd expect to find when we do our gas rate calculations. So what we're going to do now, we're obviously going to remove our burner pressure testing equipment, but again, we always do that on a dead gas supply. So we're going to turn the appliance back off. We're going to turn the gas supply off, and we're going to isolate the gas again at our appliance isolation valve. What we're then going to do is safely remove our gauge, and we're done with that now, so we can take that out of the way. We're going to, again, not over tighten, but we need to tighten up our test nipple. Okay, please don't over tighten those because you might shear them off. Now what we need to do, like any test point, we need to check that for leaking with leak detection fluid. For this, that means we have to have the appliance reignited. Okay, not just the pilot light, but actually the main burner ignited. The reason being, the solenoid valve actually stops the flow of gas past this point unless the main burner is alight. So we have to always check burner pressure test points with the main burner ignited. Okay, so point of isolation back on. Let's relight the appliance. Allow that pilot light to establish for a few seconds, which it has nicely. We can now turn our appliance back on, and with our leak detection fluid we can just prod some into our nipple. Now if we saw bubbles coming out of there, then we would suggest we have not tightened it correctly, and we'd have to address that. But it's not bubbling out, which means we've tightened it up satisfactorily. Again, remember to remove any excess leak detection fluid from our test nipple. What we could then do, we could gas rate that in the way we already know how to do, and we would make sure that hopefully we should now achieve 10.15 kilowatts gross as per the appliance data plate. So we can turn the appliance off, leave it in a safe manner.